What's up, everybody? Welcome to our exciting journey through some of the world's most incredible megastructures. We're talking about the kind of projects that make you want to put on your engineering hat and say, "Hold my juice box, I've got an idea." Today, we'll explore how these engineering marvels are built and what makes them so unique. We'll dive deep into the challenges, the innovations, and the sheer determination that brought these behemoths to life. Get ready to be amazed by the wonders of modern engineering. First up, we're heading to Dubai, home to the tallest structure on Earth, the Burj Khalifa. This towering skyscraper pierces the clouds at over 2,700 feet. Building this high requires insane precision and strong materials. Reinforced concrete is pumped to record-breaking heights. Special glass withstands intense desert heat, designed to handle high winds and earthquakes. We're traveling back to ancient China, where over 2,000 years ago construction began on the Great Wall. This network of fortifications stretched over 13,000 miles to protect China from invaders.
Imagine moving millions of tons of stone and earth without modern machinery. They relied on manpower, using ramps to move materials. This monumental effort spanned centuries and involved millions of workers.
Now, let's set sail to Panama, where we'll witness the marvel of the Panama Canal. This 50-mile waterway is basically a shortcut for ships connecting the Atlantic and Pacific Oceans. But carving a path through a continent is no easy feat.
The engineers had to overcome treacherous terrain, deadly diseases like malaria, and the constant threat of landslides. They used a system of locks, which are kind of like giant water elevators, to raise and lower ships over the continental divide. It was a massive undertaking that revolutionized global trade and still blows my mind to this day.
Chapter 4, Hoover Dam, Taming the Colorado River. Our next stop takes us to the United States, where we'll explore the Hoover Dam. Built during the Great Depression, it harnessed the Colorado River, providing electricity to millions.
Building it was like playing Tetris with giant concrete blocks. Over 3 million cubic yards of concrete were used, enough for a highway from San Francisco to New York City.
They even had to divert the Colorado River while building the dam, a feat in itself. Tidal Channel tunnel under the English Channel. Ever wondered what it would be like to travel underwater? The Channel Tunnel makes that a reality. This 31-mile tunnel connects England and France.
Building it was no walk in the park. Massive tunnel boring machines, or TBMs, were used. They had to meet perfectly in the middle. Talk about pressure.
Chapter 6, International Space Station. Out of this world engineering. Next stop, outer space. The International Space Station, or ISS, is a testament to what happens when countries come together for a common goal. This orbiting laboratory is about the size of a football field and has been continuously inhabited by astronauts from around the world for over 20 years.
Building the ISS was like assembling a giant Lego set in space. It involved multiple spacewalks and the use of robotic arms to connect different modules, all while orbiting the Earth at 17,500 miles per hour.
Back on Earth, we're heading to China to see the world's largest hydroelectric dam, the Three Gorges Dam.
This megastructure is over 1.5 miles long and holds back the mighty Yangtze River.
Creating a reservoir this massive meant relocating entire towns and villages and submerging vast areas of land.
The dam generates enough electricity to power millions of homes, but it also came with environmental impacts that sparked debate around the world. Large Hadron Collider unlocking the secrets of the universe. Ever heard of the God particle? Well, the Large Hadron Collider, or LHC, is where scientists are trying to find it. This massive underground tunnel, located near Geneva, Switzerland, is basically a giant particle accelerator. It smashes protons together at nearly the speed of light, creating tiny explosions that help us understand the fundamental building blocks of the universe.
Building the LHC was like creating the world's most precise science experiment. It involved installing over 9,000 superconducting magnets, which are kept incredibly cold to steer the particle beams.
Chapter 9, Palm Jumeirah, an island paradise. Man-made Dubai is at it again, this time building entire islands from scratch. Palm Jumeirah is a man-made archipelago shaped like a palm tree, complete with luxurious homes, hotels, and even its own monorail.
To create this island paradise, engineers dredged millions of cubic meters of sand from the Persian Gulf and carefully shaped it using GPS-guided dredgers. It's like playing SimCity in real life, but on a much grander scale.
Chapter 10, Sydney Opera House, an architectural masterpiece. Finally, we're heading down under to Australia to admire the iconic Sydney Opera House. This architectural marvel is famous for its unique sail-like roof, which has become a symbol of Australia.
But those beautiful shells were also a nightmare to build. The original design didn't account for the complexity of the curves, and it took years of innovative engineering and problem-solving to figure out how to actually construct them. The end result is a testament to human creativity and ingenuity.
That's a wrap. Thanks for joining us on this incredible journey through some of the world's most amazing megastructures. From the towering heights of the Burj Khalifa to the depths of the Channel Tunnel, we've seen how human ingenuity knows no bounds. We hope you enjoyed learning about how these engineering marvels were built. If you're like me, you're probably already brainstorming your own megastructure ideas. Don't forget to like, subscribe, and hit the bell icon for more exciting content. See you next time.